Dear students, warm welcome to the module on combined gas equation. If the temperature, volume and pressure of fixed amount of gas vary from T1, V1 and P1 to T2, V2 and P2. That means a gas is changing from state 1 to state 2. In the state 1, temperature is T1, volume is V1 and pressure is P1. And in the state 2, it is T2, V2 and P2. We can write the ideal gas equation for these states. For the state 1, we can write it as P1 V1 by T1 equal to N into R. And for the state 2, P2 V2 by T2 equal to N into R. Here number of moles is found to be constant. So in the above two equations, you can see that the right side is a constant. That means number of moles into universal gas constant is a constant. So we can change the equation or combine this equation, we will get P1 V1 by T1 is equal to P2 V2 by T2. This equation is known as combined gas law or combined gas equation, which gives the relationship between pressure, volume and temperature at a fixed amount of gas. Dear students, now we shall derive the relationship between density of a gas and its molar mass. For this, you have to write the ideal gas equation once again. What is that equation? Yes, PV is equal to nRT. Now we can rewrite this equation like this. That means N by V is equal to P by RT. What is N? N is the number of moles. How can we calculate number of moles? Number of moles of a substance is equal to mass by its molecular mass. So what will be the equation? N is equal to M divided by capital M, where small letter m is mass of the substance or mass of the gaseous substance, M is the molar mass or molecular mass. So you have to substitute the value of N in the ideal gas equation. So the ideal gas equation now becomes M by M into V is equal to P by RT. We know that M by V is equal to density. So we can write D divided by M equal to P by RT. What is D? D is the density. So the equation on rearranging, it becomes M is equal to dRT by P. This equation gives the relationship between density and molar mass of a gaseous substance. Gases having higher molecular mass or molar mass have higher density because they are directly proportional. Now let us solve one problem. You please note it. At 25 degrees Celsius, 760 millimeters of mercury pressure, a gas occupies 600 milliliter volume. What will be its pressure at a height where the temperature is 10 degrees Celsius and the volume of the gas is 640 milliliter? We will just go through this problem. You can see that here temperature 25 degrees Celsius is given, pressure 760 millimeters of mercury is given and a volume is 600 ml. This can be taken as state 1. So we can represent P1 as 760 millimeters of mercury and V1 as 600 milliliters of volume, and temperature 25 degrees Celsius we have to convert it into Kelvin scale. So the temperature T1 becomes 298 Kelvin. For the state 2, here the pressure we have to find out. volume is given, V2 is equal to 640 milliliter and temperature is 10 degrees Celsius. Again we have to convert it into Kelvin scale, we get 283 Kelvin. In this case, which equation we have to use? Yes, combined gas equation, that is P1 V1 by T1 is equal to P2 V2 by T2. We can substitute the values in this equation and then we can find out the value of P2 and the value is 676.6 millimeters of mercury. I think you all understood about this combined gas equation and how can we solve a problem related to this combined gas equation. Thank you dear students, thank you. We will meet in the next class.